March 8, 1942. Mile marker 103, Burma Road, 40 miles north of Lashio. Major Louis Pick stood at the edge of what used to be a bridge and looked down at the Shuili River Gorge 300 feet below. The bridge, a steel span that had taken British engineers 2 years to construct, was gone. Japanese bombs had dropped it into the gorge 3 days earlier, and with it went the last reliable supply route to China. Behind him, trucks stretched back for miles. Thousands of them, carrying ammunition, fuel, food, medical supplies, everything the Chinese army needed to continue fighting Japan. Everything that was now stranded on the wrong side of a destroyed bridge, unable to move forward, while 300 miles ahead in China, millions of soldiers were running out of bullets, out of rice, out of hope. Pick had been sent to assess the Burma Road's condition, to determine whether it could be repaired, whether supply convoys could resume. He'd driven the full 17-mile route from Lashio, Burma to Kunming, China over the past week, cataloging damage, evaluating repair requirements, calculating timelines. His conclusion was simple and catastrophic. The Burma Road was dead. Not damaged, dead. The Japanese advance had cut the road in 17 places. Bridges destroyed, tunnels collapsed, entire sections washed out by monsoon rains. Repairing it would take months, maybe years, and China didn't have months. Pick's driver, Sergeant Tom Wickham, approached with a map case. "Sir, recon reports the Japanese are 20 miles south and advancing. We need to pull back before we're cut off. Show me the damage reports again." Wickham spread the map across the hood of their Jeep. Red marks indicated destroyed sections, bridges at Shuili, Salween, and Mekong rivers. Tunnels collapsed at Wanting and Mangshi. Road sections washed out by landslides in a dozen locations. Each mark represented weeks of repair work under perfect conditions. But conditions weren't perfect. The monsoon season was approaching. 6 months of torrential rain that would make road work nearly impossible. Japanese forces controlled the entire region south of Lashio. And even if repairs could be made, the road's capacity was limited, perhaps 5,000 tons monthly, when China needed 50,000 tons to sustain military operations. "It's not repairable," Pick said quietly. "Not in time. Not in sufficient capacity. China's being strangled, and we can't stop it." The Burma Road had been China's lifeline since 1938. Built by 200,000 Chinese laborers, mostly by hand, using picks and shovels, it was an engineering marvel, 17 miles of switchbacks and tunnels carved through mountains that rose to 10,000 feet. It had connected Kunming, China, to Lashio, Burma, where supplies could be offloaded from ships and trucked overland to Chinese forces. For 4 years, it had worked. Barely, inadequately, but it had worked. Ammunition, fuel, medical supplies, even entire aircraft disassembled and trucked in pieces, all of it flowing through this single tenuous road that kept China fighting. Now it was gone, and without it, China would collapse within months. 400 million people, millions of soldiers, the entire Eastern theater of World War II, all dependent on a road that no longer existed. Pick folded the map, made his decision. "We're pulling back to India. I need to get to headquarters and report this directly to Stilwell. What are you going to tell him?" Pick looked back at the destroyed bridge, at the gorge that had swallowed Britain's best engineering, at the impossible terrain that had defeated every attempt to build reliable transportation through these mountains. "I'm going to tell him we need to build a new road. Not repair the old one. Build an entirely new route. Through terrain that's worse than anything on the Burma Road. Through jungle so dense you can't see 10 feet. Through mountains higher than the Burma Road ever crossed. Through monsoons that drop 500 inches of rain annually." Wickham stared at him. "Sir, that's impossible." "Yes," Pick agreed. "That's exactly what it is. Impossible. But China needs it anyway, so we're going to build it. and we're going to build it in less than 5 months, because that's how long China has before it collapses completely. March 15, 1942, Allied Headquarters, New Delhi, India. Lieutenant General Joseph Vinegar Joe Stilwell listened to Pick's assessment with the expression of a man being told his house was on fire and the fire department was unavailable. Stilwell commanded Allied forces in the China-Burma-India theater, which meant he commanded the losing side of a strategic disaster. "How long can China hold without supplies?" Stilwell asked. "Intelligence estimates 6 months maximum," Pick replied. "The Chinese army is already rationing ammunition. They're fighting with pre-World War I rifles, limited artillery, no air support. Japanese forces are advancing on multiple fronts. Without resupply, Chinese resistance will collapse by September. Maybe sooner." Stilwell studied a map showing the region. Burma was gone. Japanese forces controlled it completely. The only route from India to China was over the Himalayas, the hump, where transport aircraft flew at extreme altitude through the world's worst weather to deliver supplies. But air transport was limited, expensive, dangerous. Current capacity was perhaps 1,000 tons monthly. China needed 50,000 tons. "So we build a road," Stilwell said. "New route, India to China. How long?" Pick had been calculating this since leaving Burma. From Ledo, India, the railhead in Assam, to Kunming, China, following the Hukong and Mogong valleys, crossing the Patkai Range, then connecting to the Burma Road remnants near Wanting. Total distance, approximately 100 miles through the worst terrain on Earth. How bad is worst terrain on Earth? Pick pulled out photographs from reconnaissance flights. The Patkai Range rises to 10,000 feet. Jungle so dense aerial photography can't see the ground. Rivers that flood 40 feet during monsoon season. Landslide zones where entire hillsides collapse without warning. Malaria, typhus, dysentery endemic. Tiger and cobra populations. And construction seasons limited to 6 months annually. The other 6 months, monsoon rain makes any work impossible. Construction timeline? Under normal conditions, 5 years minimum. British engineers studied this route in the 1930s and concluded it was impractical. The terrain defeats conventional road-building techniques. Stillwell looked at Pick with the cold calculation of a commander who'd run out of good options and was evaluating terrible ones. "Major, I'm going to promote you to colonel and put you in command of building this road. You have 15,000 U.S. Army engineers, access to whatever equipment you can requisition, and priority for resources. Timeline. Road must be operational by October 1942. That's 7 months. After that, China collapses and we lose the entire theater." Pick did the mathematics automatically. 1,100 miles in 7 months, approximately 5 miles per day, every day, without pause, through terrain that had defeated every previous attempt, building in conditions that made normal construction impossible, training engineers who'd never worked in tropical jungles, fighting disease that would hospitalize more men than combat. It was impossible. Completely, obviously, mathematically impossible. "I'll need authority to innovate," Pick said. "Standard road construction doctrine won't work. I'll need to experiment, to fail, to try approaches that textbooks say are wrong. You have that authority. I'll need local labor, thousands of workers who know the terrain, who can survive the conditions." "Approved. Hire anyone who can work. I'll lose men. To disease, to accidents, to conditions. The casualty rate will be higher than some combat operations." "I understand." Stilwell's expression didn't change. "But if we don't build this road, we lose China. If we lose China, Japan controls the entire Pacific theater and the war becomes unwinnable. So we build the road, whatever it costs. Clear?" "Clear, sir." Pick left headquarters with orders to accomplish the impossible. He had 7 months to build 1,100 miles of road through terrain that professional engineers considered impassable. He had equipment designed for temperate climates being shipped to tropical jungle. He had soldiers who'd trained for combat, not construction. He had disease, terrain, weather, and basic physics all working against him. What he didn't have was choice. China was dying. The road was its only chance. And impossible or not, the road had to be built. April 1st, 1942, Ledo, Assam, India. The town, barely a village, sat at the end of the Bengal-Assam Railway, the last point where supplies could arrive by rail. Beyond Ledo, civilization ended. The Patkai Range rose to the east, covered in jungle so dense it looked black from distance. Somewhere beyond those mountains, 1,100 miles away, Chinese armies were running out of ammunition. PIC established headquarters in a bamboo structure that leaked during rain, which was constantly since Ledo received 140 inches of rainfall annually. His engineering battalions were arriving by train. The 45th Engineer Regiment, colored, the 209th Engineer Combat Battalion, the 330th Engineer Regiment. 15,000 men total, most of whom had never been outside the United States, none of whom had experience building roads through tropical jungle. First priority, PIC told his battalion commanders, is reconnaissance. I need survey teams forward, mapping the route, identifying obstacles, calculating grade requirements. Second priority, establishing supply dumps every 50 miles. Third priority, road construction starting from Ledo and pushing east. We're building toward China, and we don't stop until we reach it. Lieutenant Colonel John Arrowsmith, commanding the 45th Engineers, studied the terrain maps with visible concern. Sir, these maps are mostly blank. The interior region, everything between here and China, is unexplored. We don't know where rivers are, where mountains rise, where valleys run. We're building a road through terrain we haven't mapped. Then we map as we build, PIC replied. Survey teams go forward, mark the route. Construction follows immediately. We can't wait for perfect information. We don't have time. The equipment arriving was inadequate for the task. Bulldozers designed for American soil, not jungle mud. Trucks that overheated in tropical heat. Explosives sufficient for normal rock work, not enough for the massive excavations required. Everything was wrong, insufficient, designed for different conditions. PIC requisitioned more equipment, knowing it would take months to arrive. Meanwhile, they'd use what they had. Construction began April 3, 1942. The first bulldozer pushed into the jungle 100 yards beyond Ledo's outskirts and promptly sank to its axles in mud. Engineers spent 2 hours extracting it with winches and cables. When it was finally freed, they'd advanced exactly 23 feet. At that rate, reaching China would take approximately 140 years. That night, PIC revised his approach. Standard construction techniques, scraping topsoil, establishing grade, compacting base material, wouldn't work. The mud was too deep, the rain too constant, the vegetation too aggressive. They needed different methods. We're going to corduroy, he told his engineers. Cut logs, lay them perpendicular to the road direction, create a floating foundation on top of the mud. It's crude, it's temporary, but it'll support vehicle traffic until we can build proper road base. Corduroy roads are 19th century technology, Arrowsmith objected. We're supposed to be building a modern supply route. We're building whatever works, PIC replied. If 19th century technology gets us through impossible terrain, we use 19th century technology. The road doesn't need to be pretty. It needs to reach China before China collapses. They built corduroy. Engineers cut trees, stripped them, laid them side by side across the mud, covered them with gravel scraped from stream beds. Vehicles could drive over the logs without sinking. Progress increased from 23 feet daily to 200 feet daily. It still wasn't enough. At 200 feet per day, reaching China would take 15 years. PIC pushed harder. He organized construction into 3 shifts, working 24 hours daily. He brought in elephants from local villages, animals that could work in mud that stopped machinery. He trained soldiers to use explosives for rapid excavation, accepting rough results instead of precise engineering. He abandoned textbook methods and invented new approaches based on trial and error. Progress increased, 500 feet daily, then 1,000 feet. Then, on good days with favorable terrain, a quarter mile. But favorable terrain was rare. Most days involved fighting through jungle where trees grew so densely that bulldozers had to push aside vegetation taller than buildings. Rivers that had to be bridged every few miles, each bridge requiring days of construction. Mountains where the road had to switch back repeatedly to gain altitude, multiplying the actual distance traveled, and always, continuously, the rain. Not ordinary rain, tropical deluge that turned everything to mud, that washed out completed sections overnight, that made every task exponentially harder. By May 1st, they'd completed 23 miles, less than 1 mile daily average. At this rate, the road wouldn't reach China until 1945, long after China had collapsed, long after the war was lost. Pick stood at mile 23, looking at the jungle ahead, doing mathematics that kept producing the same answer: impossible. But he kept building anyway, because impossible was still better than surrender. And somewhere ahead, beyond mountains and jungle and monsoons, Chinese soldiers were counting on a road they didn't know was being built by men who didn't know if they could finish it. The race against collapse had begun. May 15, 1942, mile 47, Ledo Road construction zone. Colonel Pick stood knee-deep in mud, watching a bulldozer attempt to push through a teak tree that was 4 feet in diameter and apparently made of iron. The blade hit, the engine screamed, the tracks spun. The tree didn't move. Behind it, 1,000 more trees just like it stretched into jungle so thick that sunlight barely reached the ground. "How long to clear this section?" Pick asked the bulldozer operator, Corporal James Mitchell from Alabama. "This tree? Maybe 2 hours with saws and axes. The next 100 trees? Week minimum, sir. And that's just to mile 48. After that..." Mitchell gestured at the green wall ahead. "More of the same. Forever." Pick had been in theater 6 weeks. In that time, his 15,000 engineers had advanced 47 miles, less than 1 mile daily. They'd lost 340 men to disease, mostly malaria and dysentery. Another 180 were hospitalized with heat exhaustion, infected wounds, or what the medics were calling jungle rot, a fungal infection that ate through skin faster than it could be treated. Casualty rate, 3.5% in 6 weeks, without enemy contact. At this rate, his entire force would be incapacitated before reaching China. The monsoon season had started early. Rain fell continuously, not showers, but walls of water that reduced visibility to yards and turned the jungle floor into a swamp that swallowed equipment. Yesterday, they'd lost a bulldozer completely. It had sunk into mud so deep the engineers couldn't find it with probing poles. Somewhere under 16 feet of liquid earth was $45,000 worth of American machinery, gone. Lieutenant Colonel Aerosmith approached, carrying a dispatch case. His uniform was soaked. Everyone's uniform was perpetually soaked. Clothing never dried in this humidity. Soldiers wore boots that rotted off their feet within weeks. Equipment rusted despite constant maintenance. The jungle was eating everything: men, machines, morale. "Supply report, sir," Aerosmith said. "We're consuming fuel at 3 times projected rates. Equipment runs constantly. Nothing can be shut down or it won't restart in this humidity. Medical supplies are critically low. We're treating more disease casualties than combat units see in actual combat. And we've got a new problem. Tigers. Tigers. Bengal tigers, sir. 3 workers killed last week. 2 engineers last night. The cats are hunting construction crews. Local workers are refusing to go into certain areas. Pick had known about the environmental challenges, the rain, the mud, the diseases. He'd anticipated equipment problems and difficult terrain, but he hadn't fully accounted for the fact that they were building through an active ecosystem that considered humans to be prey. Postguards. Issue rifles to work crews. Anyone sees a tiger, shoot it. The local Naga tribesmen say shooting tigers angers the jungle spirits. They're threatening to quit. Pay them more. We need the labor. Aerosmith hesitated. Sir, about the labor situation. We're hiring every able-bodied worker within 100 miles, but it's not enough. We need at least 30,000 additional workers to maintain current pace, and even current pace won't get us to China in time. Pick pulled out his calculation notebook. Water damaged, pages stuck together, but still functional. He'd been running the numbers continuously, trying to find some mathematical path to success. Current progress, 47 miles in 44 days. Average, 1.07 miles daily. Remaining distance to China, approximately 1,053 miles. Timeline to completion at current pace, 984 days. Nearly 3 years. But they didn't have 3 years. Intelligence reports showed Chinese resistance collapsing. Ammunition reserves were nearly depleted. Food shortages were causing starvation in military units. Chinese commanders were estimating they could hold until October, maybe November if they got lucky. 5 months. 150 days maximum. To cover 1,153 miles through terrain that was currently taking a full day to advance 1 mile. The mathematics were impossible. Literally, mathematically, physically impossible. We need to change our approach entirely, Pick said. Everything we're doing is wrong. We're trying to build a road using textbook methods in conditions where textbooks don't apply. What's the alternative? Pick looked at the jungle, hostile, alive, actively fighting their every attempt to cut through it. Then he looked at his notebook, at calculations that kept producing the same answer. Failure. The alternative is we stop thinking like engineers and start thinking like soldiers. We're not building a road. We're fighting a war against terrain. And like any war, we win by applying overwhelming force at decisive points. May 20th, 1942. Forward Command Post, Mile 52. Pick assembled his senior officers in a tent that leaked in 17 places. Outside, rain hammered down at approximately 3 inches per hour. Light rain, by local standards. Thunder rolled continuously, lightning illuminating jungle that looked like something from before human civilization existed. New operational doctrine, Pick announced. Effective immediately, we're reorganizing into 3 parallel construction groups. Each group operates semi-independently, advancing along slightly different routes, testing different approaches. Whichever group makes best progress, the others shift to support that route. We're experimenting in real time, adapting continuously. He pointed to a hand-drawn map showing 3 potential routes through the Patkai Range. Group A takes the Northern Valley route, longer distance but potentially easier grades. Group B takes the Central Ridge route, shorter but steeper, requires more cutting and filling. Group C takes the Southern River Valley route, follows watercourses, easier navigation, but more bridge work. Major Robert Thompson, commanding the 209th Engineers, studied the map with growing concern. Sir, that means we're building 3 roads simultaneously. We're already stretched thin building 1 road. How do we build 3? We don't build 3 complete roads. We build 3 rough traces, minimal clearing, just enough to determine which route is practical. The losing routes get abandoned, and all resources concentrate on the winner. We're trading survey time for construction time. Instead of spending months planning the perfect route, we test routes by actually building them. That's incredibly wasteful, Thompson objected. We'll abandon work that cost weeks of effort. Yes, but waste is acceptable if it produces results faster. Right now, we're being efficient and slow. I need us to be wasteful and fast. China doesn't care whether we used resources optimally. China cares whether supplies are flowing by October. Captain William Morrison, the logistics officer, raised another concern. Sir, triple the construction fronts means triple the supply lines. We're already struggling to maintain one supply line through this terrain. 3 simultaneous lines will overwhelm our transport capacity. Then we airdrop supplies, Pick replied. Request transport aircraft for forward area resupply. Build landing strips where possible. Use elephants and porters where aircraft can't reach. Whatever it takes to keep construction moving continuously. The plan was radical, wasteful, unprecedented. Everything in engineering doctrine emphasized careful planning, optimal resource use, systematic approach. What Pick was proposing was controlled chaos. Multiple simultaneous experiments, rapid adaptation, acceptance of failure as learning tool. But systematic approach was producing 1.07 miles daily. At that rate, China would collapse while engineers were still arguing about optimal gradient calculations. One more change, Pick continued. We're abandoning formal road standards. No more attempting to meet peacetime engineering specifications. The road needs to support 2-lane truck traffic in dry season, 1 lane during monsoon. That's the only requirement. If it's passable, it's acceptable. We can improve quality after China is saved. Lieutenant Colonel Paul Froelich, the senior engineering officer, looked pained. Sir, what you're describing isn't a road by any reasonable definition. It's a trail, a very expensive trail. Then we're building a trail. A trail that reaches China beats a road that doesn't. June 1st, 1942. Multiple construction zones, miles 52-73. The 3-group system was producing chaos, but chaos that moved forward. Group A, pushing through the northern valley, had advanced 8 miles in 10 days by following existing animal trails and widening them with minimal clearing. The road was barely 10 feet wide, winding, extremely rough, but passable by trucks in low gear. Group B, taking the ridge route, had encountered solid rock requiring extensive blasting. Progress was only 3 miles in 10 days, but the route offered straighter alignment and better drainage. Engineers were using captured Japanese explosives, salvaged from Burma, because American supplies were insufficient for the massive excavations required. Group C, following the river valley, had built 12 miles in 10 days by using the riverbed itself as foundation. They'd constructed crude fords at shallow points, temporary bridges at deep sections. During dry season, it would be the fastest route. During monsoon, it would be impassable. But monsoon wasn't the current problem. Pick moved between groups, evaluating progress, redistributing resources. By June 15th, the decision was clear. Group A's Northern Valley route was advancing fastest with least resource consumption. Groups B and C were redirected to support the northern route. Their bulldozers, personnel, and supplies shifted to expand the successful approach. The abandoned routes represented approximately 6,000 man-hours of wasted labor. In peacetime, such waste would be scandalous. In wartime, with China collapsing, it was acceptable cost for faster results. Progress accelerated. With all resources concentrated on the proven route, advance rates jumped to 3 miles daily. Still insufficient, they needed 7 miles daily to reach China by October, but trending toward possible rather than impossible. The breakthrough came from an unexpected source. Local Naga tribesmen who'd been hired as laborers but who understood the jungle in ways American engineers never could. A Naga headman named Ningthao approached Pick through an interpreter. The American road goes around the mountain. This is slow. We know paths that go through the mountain, old hunting trails, trade routes, very steep, very narrow, but shorter. Show me, Pick said. Ningthao led a survey team up what looked like a vertical jungle cliff. The trail was barely visible, just a track where vegetation grew slightly thinner, where centuries of foot traffic had worn slight depression into rock. But it went straight up and over ridges that the American route was carefully circumnavigating. "Can we widen this to vehicle width?" Pick asked his survey officer, Lieutenant Charles Parker. Parker measured angles with a clinometer, calculated grades. "Barely, sir. 18% grade in sections. That's beyond standard specifications. But if we use switchbacks, reduce to single lane with passing zones, and don't attempt it during heavy rain, yes. Technically possible. Extremely dangerous, but possible." "How much distance does it save?" "This route cuts 40 miles off the total distance. There are probably a dozen similar routes the locals know. If we use them all, we might save 200 miles total." 200 miles. 200 miles of jungle that didn't need to be cut. Rivers that didn't need to be bridged. Terrain that didn't need to be conquered, because paths already existed. Paths invisible to American engineers, but obvious to people who'd lived here for generations. Pick made a decision that violated every engineering principle he'd learned. We're using the native trails. Widen them to minimum vehicle width. Reinforce the worst sections, but follow the traditional routes. Hire every Naga tribesman who knows these mountains. Pay them triple rate for guide services. They're now the most critical personnel on this project. Within a week, the project had 27 Naga guides leading survey teams through trails that cut through terrain American engineers had considered impassable. The route began to resemble something organic rather than engineered, following the land's natural contours, using existing weaknesses in the terrain, adapting to what the jungle offered, rather than forcing what doctrine demanded. Progress jumped to 5 miles daily, then 6. On good days, with favorable terrain and multiple construction crews working simultaneously, they achieved 8 miles. By July 1st, they'd completed 183 miles. Still behind schedule, they needed to be at 250 miles to maintain pace for October completion, but the gap was narrowing. The impossible was becoming merely improbable. July 15th, 1942, mile 217, base of the Patkai Range. Pick stood at the foot of mountains that rose nearly vertical into clouds. Somewhere above, at 10,000 feet, the road had to cross. The Patkai Range, the barrier that separated India from Burma, that had stopped every previous attempt to establish overland connection between the two regions. His engineering officers gathered around terrain models built from aerial reconnaissance photographs. The models showed what words couldn't adequately describe. Mountains so steep they were essentially cliffs, covered in jungle so dense the ground was invisible from air, crossed by rivers that became waterfalls during monsoon season. 27 switchbacks minimum to gain the elevation, Captain Morrison calculated. Each switchback requires cutting into solid rock on the uphill side, building retaining walls on the downhill side. Under optimal conditions, each switchback takes 3 to 4 days. We're looking at 12 to 14 weeks just to cross the range. We don't have 14 weeks, Pick replied. We have 8 weeks to cross these mountains and reach the Burma Plains. After that, even if we finish the road, China will have already collapsed. Then it's impossible, sir. Pick had heard that word, impossible, approximately 300 times since April. He was tired of it. Impossible meant you didn't try hard enough, didn't think creatively enough, didn't want it badly enough. Here's what we're going to do, he said. We're going to blast straight through. 30% grades, 40% in extreme sections. No proper switchbacks, just steep road going nearly straight up the mountain. Vehicles will use low gear, maximum power, and chains on tires. It'll be dangerous, difficult, and will damage equipment, but it'll be fast. Sir, 30% grades violate every road construction standard, Trucks will barely be able to climb it. Coming down will be nearly uncontrollable. Then drivers will need to be skilled. We'll train them. We'll post warning signs. We'll accept that some vehicles will crash. But we'll cross these mountains in 4 weeks instead of 14, and China will still be in the war when we reach the other side. The construction of the Patkai crossing became the defining challenge of the entire project. Engineers blasted rock faces with explosives that shook the mountains. They built retaining walls from stones too large to lift, rolling them into place and stacking them without mortar. They cut drainage channels to prevent monsoon runoff from washing the road away, and watched those channels fail as rain exceeded every calculation. The casualty rate spiked. Men fell from cliff faces during construction. Landslides buried work crews with no warning. Disease intensified at high altitude where cold combined with wet to create respiratory infections that killed as surely as malaria. But the road advanced. 1 mile daily through solid rock, 2 miles on good days when explosives worked properly and landslides didn't occur. By August 10th, they'd reached the summit, 10,047 feet above sea level, the highest point on the entire route. Pick stood at the top, looking back at the road they'd carved through mountains that shouldn't have been passable, looking forward at Burma spread below, occupied by Japanese forces, but penetrable now because a road existed where no road should. "How many miles to China?" he asked Aerosmith. "From here? Approximately 850 miles. 70 days until October 1st. 12 miles per day." They needed to maintain 12 miles daily for 70 consecutive days through terrain that might be easier than the Patkai Range, but would still be jungle, monsoon, disease, exhaustion. "Then we'd better not slow down," Pick said. Behind him, the road stretched back to India, 274 miles of mud, rock, corduroy, and human determination. Ahead, China waited, dying but not dead yet. The impossible was 850 miles from complete. August 18, 1942, mile 312, Hukong Valley, Burma. The rain had been falling for 63 consecutive hours. Not ordinary rain, monsoon deluge that measured 17 inches in the past 3 days. The Tanai River, which had been a manageable 30 feet wide when engineers began building a bridge across it 5 days ago, was now a raging brown torrent 200 feet across and rising. Captain William Morrison stood on the partially completed bridge, watching his calculations dissolve. The bridge piers, sunk 12 feet into what was supposed to be stable riverbed, were tilting as the current undermined their foundations. The wooden span, half constructed, was starting to lift from its supports as floodwater rose to meet it. "How long before we lose the whole structure?" Pick asked, standing beside him in rain so heavy they had to shout to be heard. "Hours, sir. Maybe less. The current's at 11 knots now. When it hits 15, the piers will fail and the entire bridge will wash away." Pick did the mathematics grimly. The bridge had consumed 6 days of work by 200 engineers. Timber cut from the jungle, concrete mixed on-site, steel reinforcement fabricated in field workshops, approximately 12,000 man-hours of labor about to be destroyed by water moving faster than a man could run. Can we save any of it? The cables, maybe, some of the steel work. Everything else is going into the river when the piers fail. As if on cue, the leftmost pier shifted visibly, tilting another 5 degrees downstream. The wooden superstructure creaked, a sound like a ship breaking apart. Engineers on the bridge scrambled toward shore as the structure began its inevitable collapse. The pier failed catastrophically. The timber span, suddenly unsupported, twisted and broke. Thousands of board feet of lumber, hundreds of pounds of steel cable, 6 days of intensive labor, all of it swept away by brown water moving with geological force. Pick watched the destruction with no visible emotion. This was the 3rd bridge they'd lost to monsoon flooding in the past 2 weeks. The mathematics of the Ledo Road weren't just about distance and time. They were about construction versus destruction, about building faster than nature could tear down. "Rebuild it," he said. "Same location, but double the pier depth. 24 feet minimum. Use concrete instead of stone for foundations. I want it overbuilt to the point that it can survive twice the current flow rate." "Sir, that'll take 10 days instead of 6. "Then it takes 10 days. Better to build it right once than build it wrong 3 times. We're 4 days behind schedule already. Losing another week won't change the overall timeline much. But if we keep losing bridges, we'll never reach China." Morrison looked at the raging river, at the jungle that stretched in every direction, at rain that showed no signs of stopping. "Sir, can I speak frankly?" "Always. We're fighting a losing battle against the environment. For every mile we build, nature destroys half a mile. The road sections we completed in April are already washing out. Landslides are burying completed work. The jungle is reclaiming cleared areas faster than we can maintain them. Even if we reach China, I'm not sure the road will remain passable." Pick had been thinking the same thing. The Ledo Road wasn't like normal construction, where you built something that stayed built. This was organic warfare. The jungle was alive, aggressive, actively trying to consume what they created. Maintenance requirements were exceeding construction capacity in some sections. "We're not building a permanent road," Pick said. "We're building a temporary supply line that needs to function for maybe 2 years, long enough for China to stabilize, for Allied forces to recapture Burma, for alternative supply routes to be established. If the road lasts 3 years, we've succeeded. 5 years would be unexpected. 10 years would be miraculous. We're not building for permanence. We're building for immediate necessity. And if we don't finish before China collapses, then 15,000 American engineers spent 6 months building nothing in particular through the worst terrain on Earth, while 400 million Chinese people lost the war because we couldn't overcome mud and rain. The bridge reconstruction began immediately. Engineers worked in continuous shifts, drilling pier foundations 24 feet into riverbed, pouring concrete underwater using TREMI methods, building coffer dams to protect work areas from current. The rain never stopped. Men worked soaked, slept soaked, ate soaked. Boots rotted. Skin developed infections. Everyone had malaria, dysentery, or both. But the bridge rose from the river, ugly, overbuilt, engineered for conditions that exceeded every standard. When it was finally complete 9 days later, it looked like something from ancient Rome. Massive stone piers, heavy timber beams, cables thick enough to tow battleships. It was grotesque and beautiful simultaneously, testament to what could be built when you accepted that perfection was impossible, but adequacy was mandatory. The bridge held. Through floods that washed away everything else, through monsoons that should have destroyed it, the bridge held. It's still standing in 2025, 83 years later, the only section of the original Ledo Road that remains in near original condition. September 3, 1942. Mile 428, approaching Xingbuyang. The disease statistics were becoming catastrophic. Of the 15,000 engineers who'd started construction in April, 3,800 were hospitalized. Another 1,200 had been evacuated to rear area hospitals in India. 47 had died, not from combat, but from malaria, dysentery, typhus, and accidents. Captain James Kelton, the chief medical officer, presented Pick with reports that read like casualty lists from major battles. "We're losing approximately 120 men weekly to disease. Malaria is endemic. Nearly everyone tests positive. We're just managing symptoms at this point. Dysentery is constant. We've had 3 cases of cholera. And now we're seeing what the local doctors call jungle fever, a combination of infections that our antibiotics don't treat effectively." "Survivability rate?" Pick asked. 94% of hospitalized personnel eventually returned to duty. but average recovery time is 3 weeks, which means at any given moment, we have 25% of our workforce incapacitated. Pick studied the numbers. 1/4 of his engineers were sick continuously. That meant effective workforce was 11,250 men, not 15,000, and those 11,250 were operating at reduced efficiency due to chronic low-grade illness, exhaustion, and environmental stress. What do you need to improve conditions? Kelton pulled out a requisition list that was 10 pages long. More quinine for malaria suppression. We're rationing it now. Better water purification equipment. Mosquito netting for all personnel. Improved field sanitation facilities. Mobile hospitals closer to construction zones. Refrigeration for medicine storage. And fundamentally, sir, we need to reduce exposure. The work schedule is killing men through exhaustion and continuous environmental exposure. I can't reduce the work schedule. China doesn't care if we're tired. Then we'll keep losing men, sir. The mathematics are simple. Human bodies can only endure so much before they fail. We're exceeding those limits. Pick knew Kelton was right. What they were asking of these men, working 12-hour shifts in 95-degree heat with 98% humidity, soaked continuously, bitten by insects carrying deadly diseases, eating inadequate food, sleeping in conditions that prevented real rest, would break anyone eventually. The only question was whether they'd break before or after reaching China. Get me everything on your requisition list except reduced work hours, Pick said. I'll personally authorize expedited shipping, maximum priority, but we maintain current construction pace. The men are suffering, I understand that. But Chinese soldiers are dying because we haven't reached them yet. We accept our suffering to prevent their deaths. The medical supplies arrived by airdrop. Crates of quinine, sulfa drugs, mosquito netting, water purification tablets. Conditions improved marginally. Disease rates dropped from catastrophic to merely terrible. Men kept building. September 15, 1942, mile 502, Mogong Valley. They crossed the 500-mile mark on September 15th, exactly 165 days after construction began. 500 miles in 5.5 months. Average, just over 3 miles daily. At that rate, reaching the 1,100-mile mark would take another 200 days. April 1943, 6 months after China's projected collapse. But something had changed in recent weeks. The construction crews were no longer following American engineering doctrine. They'd evolved their own methods, adapted specifically to this environment. Techniques that had emerged through trial and error, through failure and adaptation, through the desperate innovation that comes from attempting the impossible. Corduroy roads had given way to floating construction, building road surfaces on top of mud rather than trying to drain the mud. The roads moved, shifted, settled continuously, but they remained passable. Engineers had stopped trying to achieve stable foundations and instead built flexible surfaces that accommodated instability. Bridge construction had evolved from formal engineering to rapid fabrication using whatever materials were available. Timber from the jungle, steel from wrecked vehicles, cable from dismantled equipment. Bridges that looked like abstract sculptures, but somehow carried truck traffic. They weren't beautiful, weren't permanent, but they worked. Rock excavation had become systematic demolition. Engineers would drill holes in rock faces, pack them with explosives, detonate entire cliff sides, then use bulldozers to shape the rubble into road base. It was crude, dangerous, and vastly faster than conventional cutting and grading. Lieutenant Colonel Aerosmith, documenting these innovations for potential training manuals, wrote, "The Ledo Road is not being built according to any known engineering principles. It represents an entirely new construction philosophy. Absolute pragmatism in service of necessity. Every standard has been abandoned except one. Forward progress. Everything else is negotiable." The pace was accelerating. September's average, 5.2 miles daily. October's projection, 7 miles daily. They were getting faster as they learned, as methods improved, as crews developed skills that couldn't be taught in classrooms. But they were also approaching Japanese-held territory. The road route would pass within 50 miles of Japanese positions. Engineers working at the forward edge of construction would be within artillery range, potentially within patrol range. The project was transitioning from engineering challenge to combat operation. PIC requested military protection. The request was approved. Elements of the 5307th Composite Unit, Provisional, who would later be known as Merrill's Marauders, were assigned to provide security for forward construction zones. Engineers would work with infantry squads providing perimeter defense. Construction continued, but now with armed guards watching the jungle for threats more immediate than tigers. October 1st, 1942. Mile 614, near Xingbuyang. The deadline arrived. According to the original timeline, the road should have reached China by October the 1st. Instead, they were 614 miles from Ledo, approximately 486 miles short of the Chinese border. PIC received a dispatch from Stilwell's headquarters. Report status and estimated completion date. PIC calculated based on current progress rates, remaining distance, and deteriorating Chinese military situation. His reply was one sentence. Road will reach China by February 1943. Request assessment of whether China can hold until then. The response came back 36 hours later. Chinese forces collapsing faster than projected. Critical supplies must reach Kunming by January 15th latest. This is absolute deadline. After that date, Chinese resistance will be ineffective regardless of supply arrival. January 15th. 105 days from October 1st. Remaining distance, 486 miles. Required pace, 4.6 miles daily every day, without pause, through terrain that was becoming progressively more difficult as they approached the mountainous Chinese border region. And winter was coming. The monsoon season was ending, which meant rain would decrease. But mountain passes at 8,000+ feet elevation would face snow, ice, temperatures dropping below freezing at night. They'd be trading drowning hazards for freezing hazards. PIC assembled his senior staff. New operational directive. We're going to sustained maximum effort from now until completion. No days off, no reduced schedules, no pauses for weather or holidays. We work continuously, and we advance minimum 5 miles daily. Anything less means we fail. Sir, Major Thompson said carefully, the men are exhausted. We've been pushing hard for 6 months, asking for increased effort when they're already at limits. Is asking them to do the impossible, PIC finished. Yes, I know, but I'm asking anyway. Because Chinese soldiers are dying while we're having this conversation. Every day we delay reaching China costs lives that we could save. So we don't delay. We push harder, and we reach China in time, and then we can rest. The work pace intensified beyond what anyone thought sustainable. Shifts expanded from 12 hours to 16. Rest periods decreased. Engineers worked until they collapsed, slept until they could stand, then worked again. Equipment was run until it broke, repaired in the field, run until it broke again. The casualty rate increased. More disease, more accidents, more men pushed beyond human limits and breaking. But the road advanced. 5 miles daily in October, 6 miles daily in November. On exceptional days, with multiple crews working simultaneously on favorable terrain, 8 miles. By November 30th, they'd reached mile 783, 317 miles remaining to the Chinese border. 45 days until the January 15th deadline. The mathematics were still impossible. But the impossible was getting closer to possible every day. And in China, armies that were nearly out of ammunition, nearly out of hope, held their positions and waited for a road they'd never seen, built by men they'd never met. Because the alternative was surrender. The race against collapse entered its final phase,